português bem compreensível, ele fala de forma bem pausada, bem fácil de compreender. Piotr, do you stand up or sit down? Here?
I will manage.
You finish your presentation? That's okay?
That's all right.
Okay. Piotr, you have 1 hour. That's okay? You can start now. Thank you.
Very good morning, ladies and gentlemen. I should probably start with some words in Portuguese, but honestly I haven't mastered yet to learn anything apart from bom dia, so say that. And I'm quite impressed how many of you sacrificed your holiday break to come here. I hope it will not be wasted time for you. And the question to start with, how many of you would identify yourselves as geomorphologists? Not too many, which is good, because in this talk I'm not going to go very much into geomorphological detail. Rather, my intention is to provide a sort of broad overview of some of the most fascinating landscapes that exist and which I had the privilege to see. And having said that, I must say that I'm immensely grateful to Robson for the invitation to come here, and not only to you this morning, but to Fortaleza, to northeast part of Brazil. You may know that we've already had more than a week in the field. We saw some sandstone terrains, we saw some granite terrains, and they were absolutely fantastic. And I incorporated a very little of that into this presentation, but surely if I ever have a chance to talk about granite landscapes of the world again, the talk will be full of examples from here, from Brazilian northeast, where I was so expertly guided by Robson and Fred in the last few days. Okay. To start with, I've been working, or I've been interested in granite geomorphology for more than 30 years by now. I'm quite an old person. And it's actually not very easy to find partners with similar interests. If you go to textbooks of geomorphology, if you follow the list of sessions at international conferences, you will see that contemporary geomorphology is usually divided according to principal processes involved. So people say, I'm doing weathering, I work with landslides, I'm a fluvial geomorphologist, perhaps I'm a karst geomorphologist. So it is the process which defines geomorphologists nowadays. Where is granite? If you want to do granite geomorphology or sandstone geomorphology or some of the volcanic rock geomorphology, how is it? Where that fits in? So how the study of rock landforms fits the division. In the past, we used the term structural geomorphology quite often. Today, it's more appropriate to talk about, it's very small print, I'm sorry for that, rock control. So we look at different instances of how rock properties, how tectonic history control the development of landscapes. And if you look at things from this perspective, you would find possibly many partners, because someone may be a fluvial geomorphologist but working with bedrock rivers on granite. Or a person could be a very much landslide man or woman, but investigating landslide in granite terrains on regolith covered slopes. So there is a large scope, and actually probably quite a big community of people working in granite, but they don't quite identify themselves with a team, which is so kind of sad. I mentioned karst here, and the karst is, in most cases, is limestone geomorphology, you may say. So again, identified through a specific kind of rock. If you compare limestone geomorphology and granite geomorphology, you will quickly arrive at the conclusion or impression that they are quite comparable in terms of diversity, the semi-beauty, and granites are as widespread in the world as limestones, but there is still much less research on granite and much less visibility of this research internationally. Why is that? What are the possible reasons for this relative neglect of granite geomorphology? Some people say that there are not many and not very obvious distinctive environmental issues associated with granite terrains. Like in karst, where the groundwater pollution is so important, groundwater supply. This is not quite true, because in some granite terrains you have very impressive mass movements which pose a direct threat to people, to communities. Another reason in the contemporary geomorphology, which is so much process-oriented, we want to investigate the process, we want to know the rates of how quickly things change. Granite surfaces seem quite stable and change slowly. So the assumption is that, okay, there is nothing, it's not worth the effort to monitor the change because the change will be minimal. This is often an assumption rather than something proved. And we actually had a chance to talk about it yesterday in the field that could be worth starting to monitor the development of honeycombs, some very specific features. And finally, in karst, there is dissolution, which is the principal process, and everything in one way or another relates to dissolution. So this is the sort of an overarching theme. Do we have such a theme in granite? Not immediately, but I will come at the end of my talk to a proposal for such an overarching concept, something that would unify the different approaches, whether from hill slope, fluvial, or weathering, or glacial, or any other approaches. So, that was actually the introduction. Now, what I'm going to do is to show you the variety of granite landforms and landscapes, the differences the landform is something singular. So this is the landform, whereas the landscape is something much broader. These are not identical things, and I hope you will see that in a few minutes. Of course, showing diversity in science is not enough, so we want to explain the diversity. So I will offer some thoughts about that, why so much diversity. Going towards this general concept, this overarching theme, and at the end, that could be useful for you, if you are not yet decided what to do in the future within geography. Maybe you find something interesting in the research agenda, which can be followed. And at the very, very end, when you will be all totally exhausted, I will go beyond geomorphology just for a few minutes. So let's review this diversity, and we will move initially from smaller to bigger, and probably the most distinctive medium-scale individual landforms in granites are boulders. And these here are about 2 meters, between 1 meter and 2 meters long. But boulders in granites can be actually much, much bigger. I mean, if you look at this giant thing, and here is the person standing. So this is probably something like 8, maybe 10 meters high, 15 meters long, and it's monolithic, it's not jointed. So this is something very special, I would argue, for granites. Other types of rocks have joints, foliation plates, bedding planes in sedimentaries. Granites can be very, 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 very massive. But this massiveness does not guarantee survival forever. This boulder, look, it broke down into 3 pieces. Here is another person standing, right from here to there. So again, you can appreciate how big this figure is. The boulders you see here and there, they are all rounded. But this is by no means universal characteristics of granite boulders. Because if you look at these features here, they are all angular. So they have very sharp edges. Why is that? Well, you may notice that here is an exfoliation going on around, which contributes to rounding the boulder. There is no exfoliation going on here. There must have been some other mechanism, some other way of breaking down the rock, which produced angular boulders. And I don't think you have too many, if any, angular boulder fields here in tropical Brazil, but they are very, very common if you move to higher latitudes like Central and Northern Europe. Moving up, or scaling up, going to larger landforms, we have tors and crags. There are many terms used in literature. Often they don't help, they make additional confusion. You can see that these isolated residuals may take different shapes. Quite massive, separated into columns. This one is rather subdued and platy, with the main discontinuities being horizontal. This one is actually quite big, something like 30 meters, and with almost no horizontal bedding planes, but the very clear vertical ones. What they all have in common and how tors are defined. This is a strange term because this is derived from a local dialect used in Wales. Wales is a part of Great Britain. They speak a language which no one can understand. There was a very famous British geographer whose name was David Linton, and he wrote in 1955, so that was very, very long ago, but if the fact that something was written long ago doesn't mean it's useless. We have to return to, that's my advice to the young generation which prevails in this room. The fact that something doesn't exist in the internet does not disqualify it. So there are other resources than the web. Go to them. They may still be worth consulting. They have a status of classic publications, or maybe someone has already put it into internet, I don't know. But Linton in 1955 offered an explanation of how tors developed, and he also provided this kind of definition that these are the solid rock outcrops as big as a house, so 10, 15 meters high, that's approximately the maximum, rising abruptly from the smooth and gentle slopes of a rounded summit or broadly convex ridge. So we have a general landform which could be a slope, which could be a ridge, which could be a plain, and in one place there is a rock outcrop that rises above it, and this is what you saw in all these examples. A plain, a slope, a convex ridge, and something rising above. So these are tors. Moving to even bigger features, and you recognize the familiar Brazilian landscape over here with the domes. And dome, this is a self-speaking term that tells you about the shape. And domes may be up to 400 meters high, perhaps even more than that. They may occur in isolation, they may be close to one another, like those in the Mojave Desert. There is again a sort of possible terminological confusion. What's dome, what's Inselberg, how they relate to one another. Well, let me use examples from here, from our trip these days. Inselberg is the name derived from German language, and it literally means an island hill. So a hill which is like an island rising from the ocean surface. So it's flat around and there is one elevation. So this is an Inselberg, this is an Inselberg, because what is around is more or less flat. Dome, if you use the term dome, it doesn't mean any specific context, geomorphic context. Dome is just the shape of the hill. So this Inselberg is also a dome. But these domes, which we saw in Geografia do Norte, no, that was Paraíba actually, because that was on the southern side of the river. So these are not Inselbergs. They are not in isolation. They are not rising from the plain. So there are some terminological tricks we have to deal with. From the big domes and Inselbergs, we now go down to very small scale features, and they are traditionally called microforms or minor features, and they may be of various kinds. Weathering pits, taphony, This is the geological compass, so they are not very big. Honeycombs, this is the landscape from the camera. And so I had this slide in my presentation to illustrate that these features are minor, small size, small scale. I couldn't resist to add another slide here because after I saw some of your granite terrains, I doubt that the word minor still applies. I mean, look at these rings. And Fred is not a short person. So you have him for scale. So look how big, how deep they are. These are the honeycombs inside this big cavity, but the height of the opening to the cavity is probably well over 10 meters. So these honeycombs inside would be 1 meter or so. So much, much bigger. Much, much bigger than these inconspicuous hollows which you see here. Anyway, whatever we think about the size, all these features, they add to very significant diversity or geodiversity in granite terrains. These were individual landforms. Okay, so these singular objects which you can define in space by geographical coordinates, by outlines, perimeters. Now we go to a broader scale, to landscapes. And this diagram is from a paper which I published nearly 10 years ago in Singapore Journal of Tropical Geography. And these are very simple, like ideal topographic cross-sections to show the different types of granite landscapes which I was able to identify either from my own observations or by consulting literature. And the important information here also is the difference in colors. What is in brown is solid bedrock. What is in the yellowish is the saprolite, so the product of granite weathering. So it's granite which is not solid any longer. It was broken down by weathering processes. It's still there, but if you go with a little chisel or spade, or even with your own hands, you can pick up individual crystals. So it's loose, it's not coherent any longer, but it's still there. And you see that the proportion of the regolith or the saprolite in the landscape can be quite substantial, or it may almost be non-existent. It's usually non-existent in mountainous terrain. The reason? Quite simple: slopes too steep to hold this unconsolidated material. So whatever is released by weathering goes down by slope processes. Landslide, slope wash, rockfall, various kinds. Let's have a look at some of the characteristic granite landscapes. What is plain? I think that's obvious. It's a very flat surface and very boring. And they may extend for really tens, if not hundreds of kilometers. This is an example of one of the most perfect plains I was able to see, which was in Africa, in Namibia. And so don't think too much about this hill because it's a dolerite plaque, so it's not granite, it's something higher here. So remove it in your minds and you will have this flattish surface continuing up to the horizon, which is more than 100 kilometers from here. But where was that photograph taken from? It was taken from the slope of an Inselberg. So some plains may have Inselbergs rising above them. So you see the distinction, Inselberg as an individual landform and a plain with Inselberg as a type of landscape, so something much broader. A specific kind of relief which was researched, identified, named as such by, I think, one of the best tropical geomorphologists and very frequent visitor to Brazil years ago, Professor Michael Thomas, a good friend of mine, author of the very good book Geomorphology in the Tropics. And so this kind of relief is dominated by closely spaced hills, so there are hills very close to each other, so no plain, pretty rough relief, but the amplitude, the relief energy, about 100 meters, and very often they are all weathered. So Inselbergs are typically built of solid rock, very tough, very strong. These are all in weathered mantle, probably with some occasional boulders, but they do not have roots in solid bedrock. They are just, individual remnants of the once solid ground. I will come back to this multi-convex relief later. For now on, just try to recall how they look like. They are dominated by positive features, by hills.